Hello, welcome to another free code session. My name is Jason Bach, and I just got done going through rocks and finally getting, I hope I'm finally done getting the nullable stuff done, and also added that repository thing. And I did a couple of little code cleanups, but there's more to do. In fact, the list that I have of things that I want to do for episodes is long. It's just a matter of finding the time, doing the time to actually do them. But there's a couple things I wanted to do actually there's another thing I want to do that just came up recently about public interfaces with only internal implementations. I'll do that hopefully in another episode soon. And then there's other things, rocks and other things, automated profiler, blah, 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 bunch of stuff. But I'm going to take a little bit of a detour and see how long we can get done with this. And this came from this algorithm. Now I don't remember where or how I found out about this. This just popped up somewhere. And this is supposedly a fast method for calculating the digits of pi. Okay. Chudnovsky, I think that's how I'm going to say it. I may be saying it wrong, and I apologize, but Chudnovsky algorithm. And so there's lots of math things here. The end of the day, though, is if you come down here, here's a Python implementation. So cool. That at least gives us, 15, 20 lines of code that in my brain I got to shift over to C#. Here's the problem, though. In C#, we have not integral types. Intrinsics, not intrinsics, primitive types, okay, like ints, doubles, those types of things. But we don't have a type that gives us arbitrary precision. And you may say, well, what about big integer? Well, big integer gives you arbitrary precision for just integral numbers. It doesn't work if I want to represent 3 over 5 or 22 over 7 or something like that. Okay. So how do we do this? Well, long time ago, there was this thing called Coplex. Remember that? And there was also some effort for a while to adding different types into .NET's BCL, and that happens all the time. But these were some interesting ideas, and they've never made it to the light of day. In fact, this one hasn't. It's called BigRational. Okay, so this one is apparently a way to represent A over B, but you'll notice that the numerator here and the denominator are represented as big integers. Okay, so the idea is, let's try to do this in C# and bring this data type in. And this may come into a screeching, crashing halt. This might be one of my shortest episodes ever, okay? Because I may try to copy this code in, and I'm expecting maybe a couple of things not to work right. But that's okay. If I can kind of tweak it a little bit, then so be it. But this may just not even work at all, because I don't even know, when was the last time? 9 years ago, apparently. So we're going to see what we can see. I don't care if it's slow. I don't care if it's not performant. I just want to see, will it work? Okay, so we're going to have some fun with that. So the first thing I'm going to do is we're going to create a project in Visual Studio. And we're just going to do a console app, .NET Core. That's fine. And we're going to call it, I'm not even going to try to, we're just going to, this. I can't, yeah, whatever. There we go. And we're going to plop it into my M drive where I put everything. Place, solution, project, whatever, I don't know. Create. And off we go. So I just need the data type, and then once I get the data type in, I'm just going to do a couple of tests with it real quick and see if it works, and then we're going to actually try to do... my license is about to expire. No, it's not. See, this is where me being an MVP, I just got renewed, And I noticed this with my 2019 preview, is that all of a sudden it goes, your license is expired or something. And I just renew it. It's like, oh, okay, you are. Because it is. And it just gets confused for a little bit. Hopefully that's what's going to happen here. All right, so we're going to put in the BigRational type over here. Let me do a raw. I'm just going to copy all this. I'm going to come in here. We're going to say add new class. We're going to call it BigRational. And do we have, how many errors? Come on, compiler errors? We got one. Okay, we got one. Why is there one down there? Oh, I don't have enough. Oh, you're kidding me. None? I mean, I guess maybe I shouldn't really be that surprised. I mean, not that Microsoft always does perfect things, but I'm guessing that this had definitely some, some reviews and stuff like that. Oh, well, it's not hurting, so I guess fine, we'll keep it that way right now. And I'm sure, again, I'm just trying to take this code as is. So let's do this. Let's do var pi is equal to new BigRational. Did I stick it into a, no, yeah, I did. Oh, because it still thinks it's in the numerics namespace. Yeah. Okay. So let's clear that out. Because we really, I mean, I get it. It's just in numerics, but that's fine. Okay, so now if we say, do we get like a way to say big integer, numerator, denominator, big integer? You can say double value, decimal. Okay, so it has some kind of, so I could say, let's just say 22 over 7. Does that know what that is? Yeah, because I think it has automatic conversions with them. So now if I say console out right line pi, what does pi look like? And run that. 22 over 7. Okay, is there a way to say like toString? Like, does it have like a way to do the No, it doesn't. So I guess it's going to be a little weird because, like, I want to get the fraction part, get the whole part. Okay, so let's do this. Just say let's get the whole part, and now let's get fractional part, which I don't know how much that's going to help me. Yeah, because you get 3 and then 1 over 7. Like, that really helps. What I wanted to do is actually like print out the math to it. You know, so this isn't really going to be that helpful. In that I'm not going to get I want it to divide out and give me like a number representation for the BigRational, and it doesn't seem like there's a way to do that. Though what I could do is I could say you can get the denominator and you can get the numerator, and what I could do is, once I do that algorithm, is go to Alpha Wolfram and just say, here's the big numerator, here's the big denominator. Just go divide them and see what you come up with. So yeah, that would be one thing you would definitely need added on. Okay, so seems like it works. Okay, let's come over here. For greater precision, more distance, try passing in a bigger K, a bigger precision, and a bigger disp. Whatever a disp is. And then pi, so we're going to have to play with the data types here and see what we get. Actually, if we just make all these BigRationals, then this should be okay. So let's create a private static, and it returns pi, right? Yeah. BigRational calculate pi. We're going to need a big rational you can't do this as a constant, that they're arbitrary values. So you're going to have to pass in what they are. Okay, that's fine. Max k, big rational prec, and I usually wouldn't call my variables this, but I'm just trying to follow what it's doing, and we'll just, I don't know, you can say return new big rational of 22/7. By the way, if you don't know what I'm getting at, if I say 22 divided by 7, that's a very rough approximation to pi. That's why I'm doing that. So if I say console right line calculate pi, where I could do a new big rational of 70. Does it just have one? No, you have to. Oh yeah, you can't. You can do a decimal. I think that's an M, isn't it? Yeah. Okay. And then a new BR, which is 1008. Not knowing at all what these things mean. New big rational, and then this is what? 1007. No, I would not. Oh, sorry. I did something wrong there. What did I do wrong? Yeah, I forgot one there. Okay. Boom! We're done. Back it up. Okay. So let's actually do this now. Get context as GC. I don't know what that means. I really don't. I have no idea. Just kind of curious. Python GC. Is that the garbage collector or something? Yeah, garbage collector interface. Huh, I guess I was right. And then there's a prec, precision. Really? Why would that be in a GC? That seems really weird. Get context is GC. So from decimal, import decimal is dec. And get context is GC. Python decimal get context. So it's some kind of context related to decimal. And I don't think we really have to worry about that. Okay. Come back over here. So it seems like these are just declaring variables. KMLXS is equal to 61135. Okay, so we have, again, bad variable names, var. K is equal to new big rational of 6. Var, what did I just do? Var M is equal to, that'd be 1, new BR 1. These got to be m's because it doesn't understand an integer. Var L is equal to new BR. Don't want to guess. X is 1. And then S is also S. Alrighty. So We set the precision. So I don't even know if I really even need precision, right? You know what I'm going to do? I'm going to copy this, and we're going to put this into, yeah, this data sp thing. Okay, so prec, you just print that out. Yeah, so we don't care, actually we don't care about precision at all. That doesn't really seem to matter to us because we're going to have arbitrary precision, so we don't care. And then what is disp? I don't even think we would need the max k. I think we do. I don't think we're going to need disp, but I could be wrong. Okay, so let's come back here. It looks like we're just basically doing a loop for var k equals 1 k so does k just, well, is that a comment? Is that a comment? I don't know. I don't know. Python comments. Now it's basically true. A single line is good for. Yeah, how do you write comments? What does a comment look like? Ah. Okay, so then that does make some difference. People that probably know Python are just laughing at me right now, going, "Ha ha ha! You're an idiot." Times Python. What is this? What does double slash mean? The bl operator does Python's version of integer division. Oh, so it's kind of a... In Python 3, bl is what is called floor division. Does BigRational even have the notion of a floor? No. Okay, so then what does that mean for, if I can look at this and go, so we're trying to do M. I'm trying to look at this and see if I can, okay, so here. Ah, okay. So, okay, K, that's a power, okay. And then we're doing, it doesn't seem like you have to worry about doing that kind of divide. Maybe? I don't think so. Let's just try. Let's just try. Okay, so back to the, I think I'm just going to consider that to be a divide. And then so we want to say for BigRational k is equal to 1. Oh, does it have an automatic conversion? Ah, fine, whatever. This is so hacky. K is less than max k plus 1 k plus plus. You smart enough to do that? Huh? I guess so. Okay, so then M is equal to K. I don't think it knows what that would be, right? Yeah, it's not going to know what that kind of operator is. But what we can do is just say K times K times K. That's just like 4 to the 3 is 4 times 4 times 4. So K times K times K. Okay, and then that needs to be minus 16 times k. I'm just going to put the braces around just so I can keep some sense to my head. Okay, and then times m divided by k to the 3. And you're going to be just k times k times k. And it's just that easy. L plus, does it have that as an overload? I don't even know if it knows what this means. We're going to find out. Okay, well, it does know that. X times equals. You're okay with that. What is the deck? I don't understand what S is being used here for. Oh, you use it at the end. Okay. What's Python deck? Oh, it's because you're trying to... I'm going to... Because deck comes from... Wait a minute. Decimals deck. Decimal type. Python cheat sheet. So you're just saying get a decimal of that. Oh, I don't care about that. We're going to divide it by x. Okay, so I believe say m times L divided by x. And you're okay with that. Why do you say it's... Oh, because it's never used. Fine. And then k is plus equals 12. Okay. Var pi is equal to for oh boy, this is going to be fun. How do I do a square root of that? Times new. Yeah. You don't like. Wait a minute. Yeah, and then divide. So yeah. Divided by s. But we need to do the square root. Here's how stupid I am. Calculate square root. Manually. Oh, come on. I don't want to do all this crap. Just... What's... Method of computing square roots. Because I'm too stupid to remember this. The Babylonian method. Fine. Private, static, BigRational. get square root. And I could just put it in the BigRational, but b. We're just going to do for because it's a copy. So we're going to say it's b is equal to, what is s? Oh, the original number. Okay. Not in a for loop. Our s is equal to b. So we're going to keep a copy of that. So b is equal to the current b plus s over b divided by 2. And it's just that easy. Write unit tests. I'm screaming in my head right now, write unit tests. That's right. Okay, well, hold on. Original s divided by 2. Why not? Okay, so going back to the thing here, we need to do the square root of that. So get square root of that, return pi. And it's just that simple. See it blow up. Okay, you just gave me a bunch of gobbledygook here. I have no idea if it's correct. Okay, so let's do, I think it's that, var pi is equal to that, right? So we're going to say number is equal to pi. Right? Okay, and then we're going to say numerator and denominator. Numerator is equal to pi numerator. And the denominator is equal to pi the denominator. Okay, we're going to actually do a console out right line just to give some space here so I can see what's going on. Let's run it. Let's pull this down just a little bit. Okay, so that's the numerator. This is a bunch of crap to me. I don't think this is anywhere close. Because there's just way too much in the numerator than there is a denominator. So I don't even know if Alpha Wolfram could take this. We're gonna find out. Yeah, it doesn't even, it stops at some point. It doesn't even let you put in like the whole thing. So I have no idea. Let's do this. Why do I get so many zeros like that? That's weird. I'd love if a site could just let me do like that big number divided by that big number. Are there any sites that do that? Because then at least I know if I'm like way off or like on track somehow. So Now this is... I don't want examples. I want to be able to put in... I just want to put in big numbers. Yeah, that's great. Great. Get to favorites. Compute. Data input. Feed numeric and tabular data into Wolfram for GoPro. I don't want to go pro now. I mean, I just don't want to go pro. I just want to... I don't want to go pro. Back. You stink. Well, I'm kind of screwed. I don't know how to truly say take that number and divide, and divide the two. Internet, help me. High precision arithmetic. Online. Yeah. It doesn't help. Format floating. What's fixed? Yeah, you're not. If you want a floating point, oh, so you gotta stick a 0 at the end? Oh, that'd be funny. So, what do you mean? 2.0 divided by 3.0. So that determines how much. I just want to know if I'm like close or not. You know what I mean? Well, I guess what I could do is say, take that big number, clear. This is do dot 1, 2, 3, 4, 5, 6 divided by this big number. 1, 2, 3, 4, 5, 6. You really didn't do anything. How? Really? One, 2, 3, 4, 5, 6 divided by 3, 4, 5, 6. I don't think you did what I thought you should do. Yeah, I don't think it really... I don't think it did what I thought it would do. Done. Well, that's not going to help. I don't think... I don't think it's right. So... let me just check my... I'm kind of curious if I say... Let's just do console... Oh, right line... get square root of 16m. Let's do 25, and then let's do 20. Let's not do this. Wait. I just said get the square root. I didn't. Holy crap. What is... What is that? Okay, now I'm really curious. How did it do that? So it gave you a what? 16 over 1. So if I just do this by calc, and I say 16 plus 16 divided by 16 divided by 2 is 8.5. Right? So you get 17.2, which is 8.5. Okay, so then 8.5 plus 16 divided by 8.5 divided by 2. 5. $353 divided by 68. Nine, 8, 593 divided by 4, 8. Oh wait. So we're getting closer to 4. Okay. Yeah, now see, there's no way to say reduce or something like that. Which you get what you get because you're dealing with these big ass numbers. Pardon my French. But I would assume if I could actually calculate that whole thing, that's converging to 4. Let me just do this for like an iteration of 2. What does it do then? And let's be a little bit smarter here and say is and we got 20, 25. Okay, so are they? Let's say 25 should be 5. So if I say 97 divided by 13, okay, let's ramp it up a little bit. So if I say that 5. So we're getting close. I mean, we're getting to almost 5. So I don't think it's the square root that's screwing up. I think that's actually correct. Okay, so that's fine. Let's go back and look at the algorithm. So k is 6, m is 1, l is whatever that is, x is that, s is that. Okay, and then we go into range, so small k, from 1 to, I'm guessing, less than that. We just keep adding plus plus. And so m is k to the third, or kkk. That sounded wrong. 16 times k. Wait, is it the whole thing? Just curious. I don't know where it gets the S from. Whatever. K to the K. Oh, and then that's all times that. Oh, wait a minute. I might not be doing that right. No, I'm not. So we say m times all that. Okay, that's probably what I'm doing wrong. So I say m times, I mean, I have no idea if this is going to affect the answer or not, but yeah, I'm missing one. So we still want to say m times that quantity divided by that. Okay, and then L is multiply that whole thing. X is that. S is just m times L divided by X. And then K is plus 12. And then we take the big rational of that, we get the square root of that, divided by S, and we return pi. Okay, so now if we do EC, I have no idea if these are any good or not. What I'm gonna have to do is I'm almost like, this is one of my longest episodes in a while. I'm going to do a little research, and maybe I'll just do a little quick addendum episode, or I might later on tonight see if I can find out a way to calculate this, and then I'll just tack it on to the end of this episode. So I'm not going to close it out just yet. I think that's what I'm going to do, is I'm going to take these two, I'm going to record another one later and come back and say, could I figure this out, and then I'll close it out. So I will do that.